Hello, everyone. So here is the solution to this system of circles I found online. It was actually a pretty interesting question. So what we have here are three circles that sit on a tangent, and each circle touches the other two circles um, in this fashion. So the red circle touches the other two, green here and the one here. The blue one touches the other two, the red here and the green here, and the small green circle touches the other two. Green touches the red here and touches the blue here, and all three circles sit on a tangent. So what we're trying to do is find an equation that gives a relationship between all three of these circles. So what we can start off by doing is identifying the center of each circle. So one here, and one here. Since we are doing a general equation, we don't have the length of the radius. So what I will do is I will call the radius of the large circle R1. Actually, make it even easier. RL is the radius of the large circle. RM is the radius of the medium-sized circle. And RS is the radius of the smallest circle. That's pretty easy. And what we're going to do is we are going to construct three equations based on this information and see what we can do with that. So one of the easiest things that we can actually do is construct right angled triangles. And I'll show you how to do that and how we're going to label the sides. So if I'll start with the large circle and the radius is RL. And I will connect that to the smallest circle first. So if I go from the center here to the center here, that distance and the shape here actually kind of gives it away. This distance is going to be the hypotenuse of this right angle triangle. Okay, this distance is also made up of RL, the long radius, and RS, the small radius. If we take a look at this leg of the triangle, that distance is going to be RL, the entire length of this radius, minus RS. Because we stopped at the center, so we're not going all the way down. So this vertical distance is going to be RL minus RS. Okay, so I can draw that in. So you're only going to here, and then we're going to go all the way across. So this is one right angle triangle, and I will label this side as RL minus RS. The hypotenuse, just for the sake of saving space, I won't label that, but you can see that that's RL plus RS. And this arbitrary side here, I'm going to call that A. So we have our first equation, if you remember Pythagoras, which says that the sum of the squares of the shorter sides is equal to the square of the hypotenuse. So we can write that to say that RL minus RS, and this quantity, we square that. Plus A squared is equal to RL plus RS. We're squaring this quantity as well. If you make A squared is subject of the equation, so you have A squared is equal to RL squared, sorry, RL plus RS quantity squared minus RL minus RS quantity squared. And if we actually expand this, the RLs are going to cancel. Even though our expansion of these perfect squares, you get RL squared plus 2RLRS plus RS squared minus, in brackets, RL squared, so they cancel, minus 2RLRS, and minus minus will give us a plus, and then plus RS squared is subtracted from this one. So this actually comes down beautifully. You can do this on your own. Just pause the video and expand these and simplify them, and you'll realize that the RLs cancel. So you end up with AS. So A squared is 4RL RS, or A is equal to 2 root RL RS. Okay, so you can pause the video, take the time to expand these to simplify it, and this is what you'll find. So we continue to do the same thing for the other two triangles, or the other two circles rather. So here again, we join the two centers. So this length, again, is the hypotenuse of a right angle triangle, and the length is RM for the medium size circle plus RS for the small circle. We complete a right angle triangle. So this is the hypotenuse similar to this one, is going to be RM plus RS. This length here on this leg is going to be RM minus RS, because we haven't gone all the way down, we stopped at the center. So I will mark that here as well. RM minus RS. And here we have another arbitrary length, and I will call that one B. So in a similar fashion to this one, we will have our M minus RS all squared plus B squared is equal to RM minus, sorry, RM plus, this is the hypotenuse, RS square that quantity. Rearrange and simplify again. We have B squared is equal to RM plus RS squared. And we subtract RM minus RS quantity squared. Again, if we expand these brackets and simplify, we have B squared is equal to 4 RM RS, and that means that B, we find the square root of both sides, is 2 times the square root of RM RS. We have 3 circles, so we need 3 equations. So our final one, we will join the center of these 2 circles together. So from here to here. Okay. And here, this also gives an idea how we will complete the right angle triangle. So this again is the hypotenuse, which is the length of RL plus RM, the 2 radii, they meet to form one line, which is the hypotenuse. And then to complete the triangle, we go up here in line with the center of the larger triangle, and then we complete that right angle. So what you also will notice here is that this length is parallel to this one. So this is actually our arbitrary side A plus B. So I will write that in. Up here is A plus B, this side. The hypotenuse is RL plus RM. And this distance here, I'll also write that in, is going to be RL, which is the entire distance, minus the radius of this circle, which is RM. So this is going to be RL minus RM. So this distance here is going to be RL, this entire distance, minus RM. So now we have our third set of equations, which is going to say that RL minus RM quantity squared plus A plus B quantity squared is equal to RL plus RM quantity squared. Okay, so if you make A plus B all squared the subject, you have A plus B all squared is equal to, you take this over, simplify in a similar fashion, and that gives us 4 RL RM. Okay, we take it over, expand, and simplify. The RLs cancel, the RMs will cancel, and then we'll have a minus 2 RL and a 2 RLM as well. So we get this. Then we find our square root of both sides. So A plus B is going to be equal to 2 root RL RM. And now we have here an expression for A. We have an expression for B. So we can substitute that on this side. So that finally, that gives us 2 root RL RS plus 2 root RM RS is equal to 2 root RL RM. 2 is a constant, so we can drop that off, and that leaves us with root RL RS plus root RM RS is equal to root RL RM. And here is the beautiful part of all of this. If we divide the entire equation by root RL RM RS, we are left with this. So these will cancel. So we divide by this. So RL and RS cancel to leave you with 1 over root RM plus this will cancel and this will cancel. 1 over root RL is equal to this will cancel, 1 over root RS. So a decent proof took a couple steps and a bit of creativity in recognizing that we could use right angle triangles to solve this, and this will be our general equation. And I've tried it as well, drawing the actual circles once I figured out how to get to this stage, and it all works out pretty nicely. So let me know what you think, and you can also let me know if you found another way to get to this stage.